Welcome to this online presentation. My name is Oscar Hansson. I'm the head of Reporting Officers and Research Unit at the section of Forensic Biology, Oslo University Hospital in Norway. I will give you a short introduction to STR-validator, R, RStudio, and R markdown. I will say something about validation and guidelines, and then I will say something about the key characteristics of STR kits. And I will also show you how to use the STR-validator from RStudio. Finally, I will demonstrate the use of STR-validator by calculation of heterozygote balance. And then I will demonstrate a complete automation of analysis and report generation using R markdown. STR-validator is an easy-to-use graphical user interface on top of R. It aims to simplify, standardize, and streamline validation, but it can also be used for process control and contamination monitoring of negative controls. It is a free and open source software with high quality assurance standards. I created the software during my PhD that was partly funded by the European Union 7th Framework Program. You will find more information about the STR-validator on this webpage. R is an advanced system for statistical calculations and graphics, but it is also a programming language, and it's a platform for specialized packages, similar to the apps on your mobile phone. R is free and can be downloaded from the R project webpage. RStudio is an integrated development environment for R. It greatly simplifies the use of R. It is also free and open source and can be downloaded from the RStudio webpage. R markdown is a powerful tool to combine analysis and reporting into the same document. It turns your analysis into high-quality documents, reports, presentations, and dashboards. Even this presentation is written in R markdown. You can read more about R markdown on this webpage. Validation is a process by which a procedure is evaluated to determine its efficacy and reliability for forensic casework and/or database analysis. It's a determination of conditions and limitations of a new or novel DNA methodology for use on forensic genetics. And it is referred to as validation or developmental validation. A verification is to demonstrate that established methods and procedures perform as expected in the laboratory by characterizing key features, such as stutter ratio, heterozygote peak balance, and interlocus balance, and stochastic thresholds. This is referred to as verification or internal validation. Another way to say it is if you develop your own STR kit, you will go for a complete validation or a developmental validation. And if you start to using a commercial STR amplification kit, you will go for a verification or internal validation. There are many validation guidelines out there. With the European Network of Forensic Science Institutes has compiled a very short document called the Recommended Minimum Criteria for the Validation of Various Aspects of the DNA Profiling Process. They have also a more comprehensive document called Guidelines for the Single Laboratory Validation of Instrumental and Human-Based Methods in Forensic Science. The guidelines can be downloaded from this link. In the US, they have the Scientific Working Group on DNA Analysis Methods and a guideline called Validation Guidelines for DNA Analysis Methods. And this document can be downloaded from the SIGDAM webpage. And now I will say something about the different typical characteristics involved in a validation or a verification study. A good place to start is the analytical threshold. The laboratory should establish an analytical threshold based on signal-to-noise analysis of internally derived empirical data. Determining appropriate analytical thresholds is critical to maximize allele detection. As you can see in this illustration below, where you lose some alleles if you use a too high analytical threshold, and you include some label noise if you use a too low analytical threshold. So it's important to get the analytical threshold just right. For the allele size imposition, the standard deviation should be less than 0.15 base pair, so that 3 standard deviation will be less than 0.5 base pair. Then more than 99% of the time, alleles differing by a single base pair can be distinguished from one another. A less statistical way to say it is that the precision of the instrument should be such that all measured alleles fall within a plus minus 0.5 base pair window around the measured size for the corresponding allele in the allelic ladder. The peak balance ratios of heterozygote alleles within a locus, also referred to as intralocus balance, and of alleles between all loci, also referred to as interlocus or profile balance, should be more than 60% for good quality samples. And this is an important guideline used in mixture interpretation. Stutter ratios should be characterized to indicate when a stutter can be ignored as an artifact of the PCR. When using modern STR kits, you can usually observe both single and double back stutters and also forward stutter. And these can all be analyzed using STR-validator. The estimated probability of allele dropout relative to peak height can be used to define thresholds for homozygotes. So when you observe a single peak in a marker from one contributor, you can be sure that it is a homozygote peak if it reaches the stochastic thresholds. If it is below, it will be an increasingly high risk that it is a heterozygote peak that you observed, and the other partner allele has dropped out. Now I will show you how to use STR-validator from RStudio. I will explain the STR-validator main graphical user interface, the GUI wrap functions, and also how the command line functions work. After that, I will demonstrate the use of STR-validator by calculation of heterozygote balance using the STR-validator graphical user interface. Then I will demonstrate a complete automation of analysis and report generation with R markdown.